What if the universe hid secret shortcuts through space and time? This audiobook explores the fascinating hypothesis of wormholes, theoretical tunnels that could connect distant regions of the cosmos as if we were folding the fabric of the universe over itself. From Einstein's equations to the possibility of travelling faster than light, we will discover what real science says about these cosmic portals and why, even though their existence is not confirmed, they continue to ignite the imagination of physicists and dreamers. The relevance of wormholes in modern physics is undeniable. Since their theoretical proposal, they have captured the imagination of scientists and dreamers alike. In the realm of science fiction, they have been depicted as magical doors that allow us to jump from one place to another, or even from one time to another. But what lies behind this fascination? Why has such an abstract concept found such a prominent place in popular culture? The relevance of wormholes in modern physics is undeniable. Since their theoretical proposal, they have captured the imagination of scientists and dreamers alike. In the realm of science fiction, they have been depicted as magical doors that allow us to jump from one place to another, or even from one time to another. But what lies behind this fascination? Why has such an abstract concept found such a prominent place in popular culture? However, not everything is that simple. Although wormholes are theoretically possible, their existence in practice remains a mystery. Modern physics has yet to find concrete evidence of their existence. This leads us to question: are we really ready to understand these complex structures of the universe? Or perhaps, is there something we have yet to discover that prevents us from seeing them? Wormholes also pose profound philosophical dilemmas. If we could travel through one, what would it mean for our notion of causality? Could we change past events, or would we be doomed to repeat them? These questions not only challenge our logic, but also touch on the very essence of what it means to be human in such a vast and uncertain universe. In popular culture, wormholes have found their way into movies, books, and television series. From the iconic Interstellar to the Star Trek series, they have been used as a narrative device that challenges the limitations of time and space. But are these representations faithful to science? Or are they simply a poetic license that allows us to dream of the impossible? As we explore these concepts, it is essential to remember that while the theory of wormholes is fascinating, it is also an evolving field. Scientists continue to investigate and develop new ideas that could bring us closer to understanding these structures. And in the meantime, our curiosity keeps growing. The question persists: if wormholes are possible, where are they? Could they exist in our own universe, hidden in the darkest corners of space? Some theoretical physicists suggest they might be more common than we think, while others believe they are merely a mathematical curiosity. This tension between theory and observation is what makes the study of wormholes so captivating. In conclusion, wormholes are more than a theoretical concept. They are a symbol of our relentless quest to understand the universe. They invite us to question our own existence and the role we play in this vast cosmos. And while we still have much to learn, exploring these ideas brings us one step closer to unraveling the mysteries of time and space. So, as we navigate this journey through wormholes, keep an open mind. Each discovery brings with it more questions and ultimately brings us closer to the truth about the universe we inhabit. Who knows what surprises the future holds? The only certainty is that, like wormholes, our curiosity knows no bounds. Wormholes have been a fascinating topic in physics since they were first proposed. But how did we come to talk about them today? The story of wormholes begins in the 1930s when two brilliant minds, Albert Einstein and Nathan-Rosen, came together to explore the possibilities of the universe through the theory of relativity. Together they formulated what we now know as the Einstein-Rosen bridge, an idea that suggests there could be a shortcut through space-time, a tunnel connecting two distant points in the universe. Why is this concept so important? Essentially, wormholes offer us a new way of thinking about the structure of the cosmos. Imagine the universe as a sheet of paper. If you fold that sheet of paper in such a way that two separate points touch, you could traverse from one point to another without having to cover the distance between them. That is the image that Einstein and Rosen visualized. A path that challenges our notions of distance and time. However, as science progressed, the idea of wormholes took on different forms. In 1973, physicist Kip Thorne and his colleague Mike Morris proposed a more elaborate model. Instead of merely connecting 2 points in space, their wormhole model offered the possibility of being stable and traversable for travelers. But how can a tunnel be held in space-time? That's where science becomes more intriguing. The answer seems to lie in the mysterious negative energy, a concept we will explore later. The development of these ideas was not a straightforward path. There was skepticism, criticism, and many unanswered questions. The scientific community grappled with what was possible and what belonged to the realm of science fiction. The idea of travelling through a wormhole was, for many, a fantasy. But as theoretical physics advanced, a door of possibilities opened that even Einstein had not imagined. Imagine that over the years, the notion of wormholes has evolved into a kind of modern myth. Each new discovery in physics and cosmology has added new nuances to this idea that, in its early days, seemed so distant. In the 1990s, interest in these phenomena was revitalized, driven by the popularization of science in the media and literature. Books, documentaries, and movies began to explore these fascinating tunnels of the universe. But the story doesn't stop there. Human curiosity has led physicists to wonder, do wormholes really exist? Could we one day traverse them? These questions have inspired generations of scientists to investigate beyond the limits of our current knowledge. Throughout this exploration, many theorists have proposed different types of wormholes, each with its own characteristics and possibilities. It is interesting to think that, despite the complexity of these concepts, the idea of wormholes lies at the intersection of science and fantasy. The narrative of these cosmic tunnels has woven itself into popular culture, where they have become symbols of exploration and adventure. Television series, books, and movies have captured the public's imagination, turning wormholes into a cultural phenomenon. Wormholes not only represent abstract theories, but also raise profound questions about the nature of the universe and our place in it. Throughout their history, we have seen how a concept that began as a scientific curiosity has transformed into a symbol of humanity's quest to understand the unknown. The search for answers has led to a continuous dialogue between science and philosophy, where each discovery opens new questions. The story of wormholes is in many ways a reflection of the history of physics itself. From the early ideas of Einstein and Rosen to contemporary theories, this journey has been a testament to human ingenuity. Curiosity and imagination continue to drive scientists to explore the frontiers of knowledge, challenging the laws we think we understand. So the next time you think about wormholes, remember that they are not just a topic of science fiction. They are a bridge through time and space, a reminder that there is still so much to discover in our vast universe. Each new step in this story brings us a little closer to understanding the mysteries surrounding our cosmos, and perhaps one day they will allow us to traverse those tunnels that connect our present with other times and places. The scientific adventure continues, and with it, the promise of new revelations about wormholes. The theory of relativity is one of the cornerstones of modern physics. But what does it really mean? To understand it, let's think about how we perceive time and space in our daily lives. When we travel in a car, time seems to pass the same way for everyone. But what would happen if you could move at a speed close to that of light? In that case, time would behave very differently. For you, it might seem that only a few minutes have passed, while for those observing you, hours or even days could have gone by. This is the essence of relativity. Time and space are not constants but are distorted according to the speed at which you move. General relativity, proposed by Albert Einstein in 1915, takes this idea even further. Einstein suggested that gravity is not just a force that attracts objects, but rather the curvature of space-time caused by the mass of objects. Imagine a trampoline. If you place a bowling ball in the center, the trampoline will sag. Any object trying to roll near the sculling ball will be drawn towards it. This model helps visualize how planets and stars affect the space around them. Now, what does this have to do with wormholes? Within the framework of general relativity, wormholes are solutions to the equations that describe how space-time behaves. It's as if there are hidden shortcuts in this vast trampoline of the universe. Instead of traveling across the surface, you could traverse a tunnel that takes you from one point to another instantaneously. This tunnel is what we call a wormhole. But do these tunnels really exist in space? The theory suggests that they could exist. And although no one has seen one, the mathematics of general relativity allows for their possibility. However, there is a big difference between something being theoretically possible and being tangible in our reality. Just like predicting the weather, you can have a model that says it's going to rain, but that doesn't guarantee you'll see raindrops the next day. Imagine you find a wormhole. Incredible, right? But here arises another intriguing question. How could you traverse it? Theoretically, you would need a way to stabilize it, as wormholes, as described by the theory, tend to collapse. This is where fascinating concepts like negative energy come into play. This mysterious energy could help keep the tunnel open, but the truth is we still don't know how to obtain or use it. General relativity also faces an interesting dilemma. At the heart of this theory, space and time are intertwined in a way that challenges our intuition. For example, if you could traverse a wormhole and travel to the past, What would happen to the decisions you made in the present? This entanglement between time and space is what makes relativity such a fascinating and complex field. But not everything is that simple. Einstein himself was skeptical about the possibility of wormholes. Even though his theory allowed for them, he doubted that we would ever be able to find or use them. After all, nature has ways of keeping its secrets well guarded. And so, while scientists continue to explore these concepts, general relativity becomes fertile ground for speculation and discovery. The implications of relativity are not limited to theoretical physics. They have a profound impact on how we understand the universe. When we look at the stars, we are not just seeing light, we are also looking into the past. The light that reaches our eyes has travelled for millions of years, and in that journey it has crossed the curvatures of space-time. Every time we observe the cosmos, we are witnessing a spectacle that challenges our perception of time. Relativity has also allowed us to develop modern technologies such as GPS. Without the correction made for the time dilation predicted by Einstein, our navigation devices would be inaccurate. This helps us understand that the theory of relativity is not just an abstract concept, but it influences our daily lives in ways we often overlook. So, what does all this tell us about wormholes? General relativity not only establishes a theoretical framework for their existence, but also invites us to question what we know about time and space. It challenges us to think beyond our limitations and to imagine a universe where shortcuts through time and space are possible. Every time we contemplate the mysteries of the cosmos, we are exploring the boundaries of our understanding. Relativity and its relationship with wormholes show us that the universe is a place full of surprises, where what seems impossible could be waiting to be discovered. In the end, the quest for these secrets is what drives scientists to keep exploring. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey, challenging the known and venturing into the unknown. Wormholes are fascinating, but not all of them are the same. There are different types, each with unique characteristics that make them intriguing in the realm of theoretical physics. Among these, the most well-known are the Schwarzschild wormholes and the Morris-Thorne wormholes. But what distinguishes them and why are they so important for our understanding of the universe? Let's start with the Schwarzschild wormhole. This type of wormhole is the simplest and is derived from the solution to Einstein's general relativity equations. Imagine you have a tunnel connecting 2 points in space, but this tunnel is not safe. If you tried to traverse it, you could get trapped at a point of no return, similar to how a black hole works. So, is this type of wormhole really useful for travelling through space and time? The answer is no, as in practice, you wouldn't be able to exit once you enter. This raises an intriguing question. What good is a tunnel that doesn't lead anywhere? Now let's move on to the Morris-Thorne wormhole. Unlike the Schwarzschild wormhole, this type is much more promising for travel across the universe. Imagine that this tunnel is supported by a structure that prevents collapse, as if you had reinforced walls that allow the tunnel to remain open. In theory, a Morris-Thorne wormhole could allow for the safe passage of matter, thanks to the inclusion of something called negative energy. But what exactly is negative energy, and how does it help keep the tunnel open? Negative energy is a concept that challenges our intuition. Imagine you have a sort of fuel to keep the tunnel stable. Without this energy, the wormhole would quickly close, becoming a deadly trap. So if we wanted to use a Morris Thorne wormhole for travel, we would need to find a source of this negative energy. But does this energy really exist in our universe? Or is it just a theoretical idea that we have yet to prove? The key difference between these two types of wormholes lies in their stability and how they could be used. While the Schwarzschild wormhole might be fascinating from a theoretical perspective, the Morris Thorne wormhole opens up a range of possibilities for intergalactic travel. This leads us to wonder. Could we one day build one of these tunnels in reality? And if so, who would be the lucky ones to cross it? Imagination leads us to think about how these wormholes could facilitate space exploration. Consider a journey to a distant planet. Instead of spending years traveling at the speed of light, we could use a wormhole to significantly shorten the travel time. But given the complexity of the physics behind them, it's necessary to ask, what challenges would we face along the way? Moreover, there is a rich mythology surrounding wormholes. They are often presented in science fiction as portals to other worlds or times, but real science is much more complex. How can we separate reality from fiction when it comes to these fascinating phenomena? Popular culture has fueled our expectations, but science has its own rules. Each type of wormhole also raises interesting philosophical questions. If we had the ability to travel through a wormhole, what implications would this have for our understanding of time and space? Would it be possible to change the past or the future? The possibilities are as exciting as they are perplexing. The existence of wormholes also leads us to consider their relationship with the universe as a whole. Could these tunnels be pathways connecting different regions of the cosmos or even different universes? Theories about multiverses and parallel dimensions intertwine with the idea of wormholes, opening up a horizon of possibilities that is hard to imagine. In summary, the Schwarzschild and Morris Thorne wormholes represent two sides of the same coin. While the former is a fascinating theoretical concept, the latter offers a world of possibilities beyond imagination. Exploring these types of wormholes not only helps us understand relativity and quantum physics, but also invites us to reflect on the implications of the existence of such structures in our universe. So, as we delve into the mystery of wormholes, it's important to keep an open mind. Science is constantly evolving, and each discovery brings us one step closer to unveiling the secrets of the cosmos. Who knows what surprises the future holds in this exciting quest to understand the depths of space and time? The adventure is just beginning. Wormholes are fascinating not only for their potential to connect different points in the universe, but also for the physical properties that give them life in the context of the theory of relativity. But what exactly are these characteristics that define wormholes? To understand this, it is helpful to think of the fabric of space-time as a large sheet of paper. When we place a heavy ball in the center, that sheet deforms, creating a sort of bowl around it. This phenomenon is what we know as the curvature of space-time. Now imagine that instead of a flat sheet, we have a wrinkled sheet, and in the most wrinkled parts we could find those wormholes. the curvature of space-time is crucial because it allows wormholes to exist. But why is this curvature so important? The answer lies in how gravity influences the way we move and how we interact with the universe. Every object with mass generates a curvature in space-time, which in turn affects other objects. Thinking about the curvature of space-time leads us to another fascinating concept: the length of distance. If we had a wormhole, we could drastically shorten the distance between 2 points. Instead of having to traverse the vast emptiness between the stars, we could pass through a tunnel that would take us from one place to another in the blink of an eye. But what else do we need to know about their physical properties? The stability of a wormhole is one of the most intriguing aspects. For a wormhole to be functional, it needs to be supported by what scientists call negative energy. This is a somewhat strange concept, as we are used to thinking of energy as something positive, something that drives and powers. However, negative energy is essential to keep a wormhole open and prevent it from collapsing under its own gravity. How could we imagine this negative energy? Think of a balloon. When you inflate a balloon, the air inside creates pressure, keeping it expanded. Similarly, negative energy acts as a support, keeping the wormhole in its open state. Without this energy, the wormhole would quickly close, preventing any travel through it. But is it really possible to find this negative energy in nature? So far, we have not seen direct evidence of its existence, but scientists continue to investigate. The physical properties of wormholes are not limited to their curvature and negative energy. They are also related to how they behave under different conditions. For example, theoretical Schwarzschild wormholes do not allow the passage of matter or information. On the other hand, Morris-Thorne wormholes are more promising regarding the possibility of being used as intergalactic bridges, but they require extremely specific conditions to function. Moreover, the way light behaves around a wormhole is another aspect worth mentioning. Light, like any massive object, is affected by the curvature of space-time. When light passes near a wormhole, it can bend, which could make the wormhole appear smaller or even invisible. This raises the question, could we ever see these phenomena in the universe? The physical properties of wormholes also open the door to many questions about their real existence. If they are theoretically possible, why haven't we found them? The answer may lie in the scale of the universe. Wormholes, if they exist, could be extremely rare or hidden behind other astronomical structures. This leads us to reflect on how many wonders might be hidden in the vastness of the cosmos. Some scientists argue that even if we find a wormhole, the technology needed to traverse it might be beyond our current understanding. Is it possible that humanity is destined to explore these mysteries of the universe? Human curiosity has led to great discoveries throughout history, and wormholes could be one of the next great challenges. Research in this field is constantly evolving. Advances in theoretical physics and astrophysics are bringing us closer to a better understanding of these phenomena. But what does this mean for our understanding of the universe? Each discovery brings us a little closer to unraveling the secrets of creation and the structure of space and time. In summary, the physical properties of wormholes encompass a wide range of concepts that are essential for their existence. From the curvature of space-time to negative energy, each aspect helps us better understand how our universe works. Curiosity and research in this field are crucial, not only to expand our knowledge, but also to inspire future generations to explore the unknown. Who knows what discoveries await us in the future? The exploration of the cosmos is just beginning, and wormholes could be the key to unlocking new doors in our understanding of the universe. Have you stopped to think about the relationship between quantum mechanics and wormholes? Although they may seem like distant concepts at first glance, they are actually intertwined in fascinating ways. Quantum mechanics, which studies the behavior of particles at extremely small scales, may offer clues about how wormholes could function, those hypothetical passages through space and time. Quantum mechanics tells us that the subatomic world is a strange and chaotic place, where particles can exist in multiple states at once, and where the actions of one particle can instantaneously influence another, regardless of the distance separating them. This challenges our classical understanding of reality and raises intriguing questions. Could this quantum behavior be the key to understanding wormholes? A central concept in quantum mechanics is Heisenberg's uncertainty principle, which states that we cannot simultaneously know the position and velocity of a particle with total precision. This suggests that there are fundamental limits to our ability to measure and predict the behavior of particles. But what if these limits also apply to our understanding of wormholes? Some scientists have proposed that wormholes could be related to entropy, which is a measure of disorder in a system. In quantum mechanics, particles tend to be in a state of greater disorder as they interact with one another. This raises an intriguing question. Could wormholes be a manifestation of this quantum disorder, allowing space and time to connect in unexpected ways? Imagine we are in a universe where wormholes are real. How might they interact with quantum mechanics? Some theorists suggest that instead of being simple tunnels in space, wormholes could be filled with quantum fluctuations. These fluctuations could affect their stability and allow particles to behave in strange ways as they pass through. Another fascinating idea is that of quantum wormholes. These would be wormholes that exist at quantum scales, where the rules of quantum mechanics are dominant. In this context, wormholes would not be just static structures, they would be in constant change, evolving in response to quantum interactions. Could it be that wormholes are more than just passages, and are actually dynamic and vibrant? Additionally, some speculate that quantum gravity, a theory that seeks to unite general relativity with quantum mechanics, could offer answers about the nature of wormholes. This theory suggests that space and time are actually a network of intertwined quantum particles. In this framework, wormholes could be the result of complex interactions in this quantum network. But what implications would this have for our understanding of the universe? Physicists are also interested in how quantum mechanics could provide solutions to the time travel paradoxes that wormholes might imply. If wormholes can connect different points in time, then quantum mechanics could help resolve questions about how decisions in the present can affect the past. Could it be that time travel through a wormhole is not only possible, but also governed by the quantum rules of randomness? Moreover, quantum entanglement, a phenomenon where two particles can be correlated regardless of the distance between them, raises another intriguing question. Could quantum entanglement be a form of communication through wormholes? This suggests that we might not only travel through them, but also send information instantaneously across time and space. As we explore these ideas, the line between science and science fiction becomes increasingly blurred. On one hand, we have theoretical physics attempting to unravel the mysteries of the universe, and on the other, science fiction writers inspired by these concepts to create fascinating stories. Is it possible that what we consider fiction today could become science tomorrow? Wormholes and quantum mechanics challenge us to rethink our understanding of reality. They invite us to question what we know about time, space, and matter. In a world where the quantum and the cosmic intertwine, the possibilities seem endless. Each new discovery in quantum mechanics could open the door to a greater understanding of wormholes and their place in the universe. As research progresses, we are likely to continue uncovering surprising connections between quantum mechanics and wormholes. With each new finding, more questions than answers arise, leading us on an endless journey into the unknown. And on this path, human curiosity remains the driving force behind our desire to explore, understand, and perhaps one day travel through wormholes. Wormholes, those mysterious shortcuts in the fabric of space-time, have captured the imagination of scientists and dreamers alike. But have you ever considered the fascinating idea that we could use these phenomena to travel through time? The notion of jumping through the years, visiting their past, or glimpsing the future sounds like science fiction, but in theoretical physics, it is a topic that generates passionate debates. Imagine you have the ability to take a direct path between 2 points, one in the present and another in the past. Instead of following a straight line that takes us through the years, a wormhole could be that shortcut that allows us to reach our temporal destination in the blink of an eye. However, the question persists. Is it really possible? Wormholes, as conceived by Einstein's general theory of relativity, are solutions to the equations that describe how space-time curves due to gravity. But it's not just a theoretical concept. Physicists have speculated about their use for time travel, a topic that evokes both hope and skepticism. What would happen if we could go back and change historical events? Or, conversely, what if we could leap into the future and see how our civilization unfolds? Time travel through wormholes raises many questions. On one hand, there is the famous grandfather paradox. If you travelled to the past and prevented your grandfather from meeting your grandmother, could you have been born? This idea provokes a dilemma that has been explored in numerous works of fiction, but it is also a crucial point in scientific discussion. Is it possible that time branches into multiple timelines, each affected by our decisions? As we delve deeper into these questions, the concept of alternative timelines becomes relevant. If a wormhole allowed travel to the past, perhaps every action we take could create a new timeline. Imagine a world where every choice meant the creation of a new reality. Would it be absolute chaos or a vast universe of possibilities? Scientists have proposed different ways in which wormholes could function for time travel. Some suggest that to maintain the stability of a wormhole, a form of negative energy would be needed. This type of energy, which we do not yet fully understand, would be essential to keep the tunnel connecting different points in time open. But what does that really mean? Could there be a source of negative energy in the universe that we have yet to discover? Exploring wormholes and their relationship with time not only leads us to questions about physics, but also touches on the essence of what it means to be human. The idea of changing the past or glimpsing the future confronts us with the nature of free will. If we had the ability to alter historical events, should we do it? Would it be our responsibility or a burden we could not bear? Some theorists have suggested that wormholes could be a way to travel not only through time, but also between dimensions. What implications would this have for our understanding of the universe? If wormholes connect not only different moments but also different realities, we would be faced with a spectrum of infinite possibilities. However, as we let ourselves be carried away by these ideas, it is crucial to remember that all of this remains speculative. Science has not yet found concrete evidence that wormholes exist, or that we can use them for time travel. But this does not prevent scientists from continuing their research. Human curiosity is insatiable, and as technology advances, new theories and experiments are underway. The exploration of time and space through wormholes invites us to question our understanding of reality. If time is a dimension we can manipulate, what does that mean for our perception of life and death? The possibility of seeing loved ones again or avoiding past mistakes may be tempting, but it also raises profound questions about fate and purpose. So while wormholes remain a topic of intense debate and speculation, their study pushes us to think beyond the current limits of science. It challenges us to imagine a universe where time is not just a straight line, but a vast landscape filled with intertwined paths. Curiosity drives us to explore these ideas, and perhaps, in the not-so-distant future, we will discover that the secrets of time are closer than we think. So the question hangs in the air: what would you do if you had the opportunity to travel through time? Would you change the past, explore the future, or simply enjoy the journey? The possibilities are as infinite as the wormholes themselves. Wormholes are fascinating not only for their ability to connect different points in space, but also for the complexities that arise when we consider their use as bridges to time. What if you could travel to the past or the future simply by traversing one of these mysterious tunnels? The idea of time travel has been a recurring theme in science fiction, but it also raises profound questions about the nature of reality. When thinking about time travel, it is impossible not to wonder, could a wormhole allow us to visit historical moments? Imagine being able to witness the construction of the pyramids of Egypt, or even chat with famous figures from history. However, this possibility does not come without its complications. What if by altering a small event from the past you change the course of history? This idea translates into what is known as the grandfather paradox. Can you imagine travelling to the past and accidentally preventing your grandparents from meeting? This would mean that you would never have been born. How would these contradictions be resolved? Temporal paradoxes are not just a device of science fiction, they are a real philosophical and scientific dilemma. Scientists have questioned whether time is linear, or if, in some way, it can be more flexible. When we talk about wormholes and their relationship with time, it is helpful to think of time as a sheet of paper. If you fold that sheet, you can connect 2 points that are far apart. But what happens if, by doing so, you create a path that interferes with the natural flow of events? That is where the paradoxes become complicated. One of the most intriguing problems is the possibility that a time traveler could arrive at a moment when a previous version of themselves already exists. If both were to meet, what would happen? Would they cancel each other out? These types of situations have been explored in movies and books, but in reality, physicists have different theories about how things could work. Some suggest that time may be a loop, where all possibilities coexist simultaneously, while others believe that each action could create a new timeline. Quantum mechanics, on the other hand, adds another layer of complexity to this puzzle. At the quantum level, particles seem to behave in ways that challenge our classical understanding of time and space. What if wormholes could be influenced by these strange quantum interactions? This is an uncharted territory full of potential. On the other hand, there is also the question of whether wormholes can be stable. For time travel through a wormhole to be possible, a way to keep it open and prevent it from collapsing would be needed. This is where the concept of negative energy comes in. It is thought that somehow a form of energy that we currently do not fully understand would be required. The idea that we might need something as strange and counterintuitive as negative energy makes the possibility of time travel seem even more distant. Moreover, it is important to ask ourselves if we would really want to travel through time. Often, history is filled with painful and difficult events. Would you really want to be present in those dark moments? The notion that we might have the ability to change the past carries a significant moral weight. The decisions we make in the present can be complicated, so imagining resolving dilemmas from the past raises questions about our own responsibility. Temporal paradoxes are not just a matter for theorists. They have been addressed in many works of fiction. From Back to the Future to Doctor Who, popular culture has explored these ideas in entertaining and thought-provoking ways. These stories not only entertain us, but also invite us to reflect on the deeper implications of what time means and our existence within it. As we explore the possibility of time travel through wormholes, it is essential to remember that while science fiction may inspire our imagination, the reality of theoretical physics is much more complex. The mere fact that science has not completely debunked the possibility of wormholes is a testament to human ingenuity and our desire to understand the universe. In conclusion, the idea of using wormholes as gateways to time is both exciting and daunting. The temporal paradoxes and philosophical implications that arise from this possibility invite us to reflect on the fabric of our reality. In this chaos of theories and speculations, what remains clear is that our understanding of time and space continues to evolve, and with each discovery, we come a little closer to unraveling the mysteries that surround us. The notion of negative energy is fascinating and at the same time perplexing. What does this concept really mean in the context of wormholes and modern physics? To understand it, we must first break down what energy implies in our universe. In simple terms, energy is defined as the capacity to do work. But what happens when we talk about negative energy? Imagine a scenario where the force of gravity acts in a way opposite to what we know. In a typical universe, gravity pulls objects toward the center of a planet, like when an apple falls from a tree. However, in the context of wormholes, negative energy could allow certain elements to behave differently, even repelling gravity. This phenomenon is crucial for the stability of a wormhole. When discussing wormholes, it is often mentioned that they require something more than just normal matter to exist. This is where negative energy comes into play. Theoretical models suggest that to stabilize a wormhole, this negative energy is needed, equivalent to a kind of glue that keeps both ends of the tunnel in space-time together. Without this glue, the wormhole would collapse instantly. But where does this negative energy come from? A commonly used example in physics is the concept of quantum vacuum. In the vacuum of space, particles and antiparticles can arise fleetingly. This phenomenon can lead to the creation of situations where negative energy manifests. It's as if the universe, in its essence, is creating small fluctuations that could be harnessed under certain circumstances. The idea of using negative energy to stabilize wormholes is not just an abstract concept. Physicists have proposed that certain types of exotic matter, which would have unusual properties, could be the key. This exotic matter would need to possess a negative energy density, which could allow for the creation and maintenance of these tunnels in space-time. But what does this mean in practical terms? Let's think about a road. If we want to build a bridge that crosses a river, we need materials that can support the weight and not collapse. In the case of wormholes, exotic matter would be like the special building material that would allow the bridge, or in this case the wormhole, to stand without collapsing. However, the existence of this exotic matter has not yet been proven. Researchers are still searching for evidence in the universe that supports the idea that negative energy is real, and more importantly that it could be used to create stable wormholes. But what would this imply for us? Imagine one day we discover how to use negative energy to create a wormhole. Could we travel through it and reach distant places in the universe in a matter of minutes? The notion of instantaneously traveling to another galaxy becomes an intriguing possibility. But it also raises questions about the nature of time and space. Furthermore, if we could manipulate negative energy, what other wonders could we create? Perhaps we could find ways to travel through time. However, all these concepts are surrounded by uncertainties and challenges. Science still has much to explore in this area. The journey toward understanding negative energy and its relationship with wormholes is uncharted territory. Each new discovery could open doors to possibilities that we currently consider only science fiction. The quest for answers about negative energy is an exciting race, where each advancement brings us a little closer to understanding the mysteries of the universe. In a more philosophical sense, negative energy invites us to reflect on the very nature of existence. Is it possible that, in our universe, there are forces we have yet to consider? Questions about negative energy and wormholes remind us that science is a constantly evolving field where the unknown becomes an exciting challenge. As we continue to explore these ideas, we find ourselves facing a fascinating landscape filled with mysteries to unveil. The combination of negative energy and wormholes not only challenges our current understanding of physics, but also invites us to dream of a future where the limits of time and space may be transcended. In this journey, each question that arises could be a clue leading us to a monumental discovery. Is it possible that wormholes exist in our universe? This question has intrigued scientists and dreamers alike. The notion that these cosmic tunnels could connect different points in space and time opens up a range of fascinating possibilities. However, the reality is that so far, we have not found direct evidence of their existence. But why is it believed that they might be there? Wormholes are, in essence, solutions to Einstein's general relativity equations. This theory suggests that space and time are malleable, like a rubber sheet that can be bent and twisted. Imagine we have a sheet of paper. If we draw 2 points on it, the distance between them is the straight line we can draw. But if we fold the paper, those 2 points can come much closer together. Wormholes would work similarly, allowing the distance between 2 points in the universe to be drastically shortened, as if we were using a shortcut on a map. Over the years, several scientists have proposed theories about the existence of wormholes. Some even suggest that they might be hidden in the fabric of the cosmos, invisible to our current instruments. But what would happen if they really existed? Could they be detectable in some way? The answer is not simple. Perhaps our technology is not yet advanced enough to see what is right in front of us. Could it be that wormholes are there, waiting to be discovered? The idea that these cosmic tunnels could be used for intergalactic travel is one of the reasons people are so excited about them. Can you imagine being able to cross vast distances in an instant? However, science is cautious. Although wormholes are theoretically possible, that does not mean they are practical or safe. Many physicists wonder if we could traverse them without being destroyed in the process. What if entering a wormhole led us to a completely different dimension? The possibilities are captivating but also terrifying. Some researchers have raised the possibility that there are wormholes in space that could be used to explore other parts of the universe. However, detecting these phenomena is not so simple. Wormholes do not emit light or energy in the way that other astronomical structures do. So how could we find them? One possibility lies in observing how matter interacts with the space around it. If a wormhole existed, it could influence the trajectories of nearby stars or even the light passing through it. The concept of wormholes has also led to speculation about their relationship with other dimensions. Some theories suggest that they could be passages to parallel universes. What implications would this have for our understanding of reality? If other universes exist, could we one day visit them? This kind of questioning is what makes research on wormholes so exciting and, at the same time, perplexing. As we explore more about the universe, wormholes continue to be a topic of debate and speculation. Scientists conduct simulations and mathematical models to understand their possible existence and characteristics. These simulations are essential as they allow us to visualize what our eyes cannot see. Through these representations, we can begin to imagine how wormholes would behave in real situations, even if only in theory. Nevertheless, the search for wormholes raises more questions than answers. If we ever manage to detect them, what will that mean for our understanding of time and space? Will it open the door to a new chapter in the exploration of the universe? Human curiosity has a way of pushing us toward the unknown, and wormholes are one of those mysteries that invite us to keep exploring. As we advance in our understanding of the cosmos, wormholes remind us that even though it may seem like we have reached the end of knowledge, there is always more to discover. Science is in constant evolution, and each answer brings new questions. In this vast universe, where the idea of travelling through time and space feels increasingly possible, wormholes become a symbol of our tireless quest for truth. The existence of wormholes could change our perspective on life, time, and reality itself. But in the meantime, we continue to look to the sky, searching for signs of what might be beyond our reach. Who knows? Perhaps one day, in a forgotten corner of the universe, we will find that tunnel that connects everything, revealing secrets we cannot yet imagine. The search has only just begun. Have you ever wondered how scientists can represent something as abstract as a wormhole? Imagine a fold in a sheet of paper. If you bend the sheet in such a way that 2 points on its surface touch, you have created a shortcut between those 2 points. This simple action is a way to visualize how a wormhole works in the universe. However, the reality is much more complex and fascinating. Simulations and mathematical models allow us to explore this concept. Through powerful computers, physicists can create visual representations that show how wormholes might appear in space-time. Can you imagine seeing an image of a wormhole in action, with space and time bending around it? It's like watching a cosmic dance where the laws of physics twist and turn in surprising ways. What tools do scientists use to develop these models? The answer lies in mathematical equations that describe Einstein's general relativity. These equations enable researchers to simulate different scenarios in which wormholes could exist. It's as if they have a map of the universe, where each equation is a signal indicating a possible path to follow. One of the most intriguing aspects of these simulations is how they illustrate the stability of wormholes. While theory suggests they could exist, simulations help us understand what conditions would be necessary for a wormhole not to collapse. Imagine trying to balance a ball on top of a hill. It requires careful manipulation to keep it from sliding. This is how scientists visualize the stability of these phenomena in the vast cosmos. But are they just visual representations, or is there something more? Simulations also allow researchers to make predictions. For example, they can explore how a wormhole would affect light passing nearby. What would happen if a beam of light approached? Simulations can show how light would bend, creating visual effects that challenge our perception of reality. It's like seeing an optical illusion, where what seems to be is not always what is. As these representations become more sophisticated, scientists can even begin to test theories about how wormholes might be detected in our universe. Mathematical models and simulations can predict signals or phenomena we might observe in space. Imagine being able to look up at the sky and, with the help of technology, point to a place where a wormhole might be hidden. Collaboration between theoretical physicists and data scientists has also grown in this field. Thanks to data analysis tools, they can process enormous amounts of information from telescopes and space probes. Who would have thought that the search for wormholes would depend so much on modern technology? It's as if scientists are piecing together a cosmic puzzle piece by piece to better understand the universe. One of the challenges in creating these models is the complexity of space-time. Although wormholes are fascinating, they are also difficult to represent accurately. Simulations must take into account a multitude of variables, from mass and energy to how they interact with other forces in the universe. Every small change can lead to drastically different outcomes, as if you were tuning a musical instrument and each note affects the overall melody. But it's not just scientists who benefit from these simulations. The visualization of wormholes also fuels the public's imagination. By seeing these representations, people can start to think about the infinite possibilities of space and time travel. It's a reminder of how science and creativity can intertwine, inspiring future generations of scientists and dreamers. As we advance in our understanding of wormholes, simulations become more than just tools. They transform into portals to new ideas. What other theories might arise from a visual representation of a wormhole? The possibilities are exciting and often unpredictable. In summary, simulations and mathematical models not only help us understand wormholes, but they also allow us to see the universe differently. Each representation is a step toward a greater understanding of what could be and what might be waiting to be discovered. As we continue to explore, let us remember that our concepts of space and time are constantly evolving, and each new discovery is an invitation to look beyond what we know. Wormholes are not just a scientific curiosity. They may also be key to unraveling the mysteries of the universe. How are these fascinating tunnels of space-time related to cosmology, the science that studies the origin and evolution of the universe? To understand this connection, we must first think of the universe as a vast landscape filled with mountains, valleys, and rivers, where wormholes act as bridges that allow us to cross from one point to another, bypassing the obstacles that separate us. Imagine that the universe resembles a crumpled sheet of paper. If you want to go from one point to another on that sheet, the most natural thing would be to follow the surface. However, if you could fold the paper and create a shortcut, you could reach your destination much faster. This is how wormholes could function in the universe, providing more direct routes between different regions of space and time. Cosmology focuses on understanding how everything began. Through the Big Bang, the universe started to expand, creating a stage where galaxies, stars, and planets formed. But what if wormholes could offer a way to connect different epochs of the universe, allowing not only travel through space but also through time? This opens the door to intriguing questions about the very nature of time. In this sense, wormholes could act as portals that connect not only different places but also different moments in the history of the universe. From the formation of the first stars to the distant future that we have yet to explore, these tunnels could be the key to understanding how everything is connected in a vast network of cosmic events. However, the existence of wormholes in cosmology also raises fundamental questions about the structure of the universe. Are they common, rare, or in fact, non-existent. Some scientists suggest that they might exist in regions where space-time conditions are extreme, such as inside black holes. But could we find them, or even utilize their potential? Moreover, wormholes could influence how we perceive cosmology. The idea that we could travel through time and space via one of these tunnels changes our understanding of space-time. It invites us to think of the universe not as a fixed place, but as a dynamic and ever-evolving environment. Research on wormholes may also illuminate dark aspects of cosmology, such as dark matter and dark energy, which seem to make up most of the universe. Could the interaction of these mysterious components with wormholes provide new clues about their nature and their role in the expansion of the universe? The relationship between wormholes and cosmology also raises questions about the possibility of parallel universes. If wormholes can connect different points in our universe, could they also connect to completely different universes? This leads us to a fascinating reflection on the infinity of existence and the multiple realities that could coexist. As science advances, theories about wormholes continue to evolve. Cosmology and theoretical physics are becoming increasingly intertwined, allowing us to explore ideas that once seemed relegated to science fiction. The possibility that wormholes could offer a solution to some of the deepest enigmas of the universe is an invitation to keep probing and questioning our beliefs about the cosmos. Wormholes also compel us to rethink our position in the universe. If they existed, what would that mean for our understanding of life, death, and the continuity of time? Could we somehow use these portals to learn about our past, or even our future? In summary, wormholes are not only fascinating for their potential to connect distant places, but also have profound implications for cosmology and our understanding of the universe. By exploring these possibilities, we delve into a territory where physics meets philosophy, challenging our notions of time and space. It is a journey that is just beginning, and each discovery brings us closer to unraveling the complexity of the universe. Although we are still far from having definitive answers, the mere idea that wormholes could be part of the structure of the cosmos invites us to keep exploring, questioning, and dreaming about what is possible. Thus, the relationship between wormholes and cosmology is a reminder that the universe is a place full of surprises and mysteries yet to be discovered. And as we continue our quest for knowledge, perhaps one day we will manage to open a door to the unknown, a tunnel that leads us to new dimensions of understanding. Wormholes have captured our imagination in a way that few scientific concepts have. In science fiction, these mysterious tunnels in space-time are presented as gateways to other galaxies, distant times, and unknown dimensions. But how have these concepts influenced the way we tell stories and explore the human condition? From classics like H.G. Wells' The Time Machine to the series Interstellar, wormholes are narrative tools that allow us to reflect on the passage of time and the decisions we make in our lives. In these stories, travelling through a wormhole is not just a means of transportation, but a powerful metaphor for missed opportunities and paths not taken. If we could travel to the past, what would we change, and what consequences would that have in the present? A fascinating example can be found in the movie Contact, where travelling through a wormhole opens the possibility of connecting with distant civilizations. This type of narrative leads us to question our solitude in the universe. If wormholes exist, could they be the bridge to encounters with other forms of life? The possibility that we are not alone, that there are other beings exploring the cosmos, adds a layer of excitement and hope to our search for answers. In the series Star Trek, wormholes are presented as shortcuts through the vast universe. Isn't it intriguing to think that, just like in the series, we could find paths that take us to distant worlds in the blink of an eye? This type of representation not only fascinates us, but also reflects our innate desire to explore the unknown and to overcome the limitations of our time and space. On the other hand, Jonathan Swift's Gulliver's Travels can be seen as a primitive way of approaching the idea of wormholes. Through his adventures, Gulliver experiences different dimensions of reality. Although a wormhole is not explicitly mentioned, the idea of travelling to extraordinary places resembles what we might feel if we had access to these dimensional doors. The paradoxes that arise from wormholes are a recurring theme in science fiction. Movies like Back to the Future explore the complications of time travel. If one goes back to the past and changes an event, how would that affect the future? The narrative becomes a labyrinth of possibilities, where each choice can have unpredictable consequences. This complexity adds depth to the stories, turning them into a reflection of our own lives filled with decisions and their repercussions. Another interesting approach can be found in the series Dark, where wormholes are crucial to the plot. Here, the connections between the past, present, and future intertwine intricately. This series not only makes us question time, but also our relationships and the bonds we share with others. The narrative becomes a mirror of our own interactions and how our decisions affect those we love. In the realm of literature, Isabel Allende's The House of the Spirits, while not addressing wormholes literally, plays with the idea of memory and time in a way that resonates with the concepts of relativity. Family stories cross through time, showing how the past and present are inextricably linked. This type of narrative reminds us that, although we cannot physically travel in time, our stories are always present in our lives. We cannot forget the influence of Doctor Who, where wormholes are a key element for time travel. The Doctor, an intergalactic traveller, shows us that time is fluid and that our experiences are connected in unexpected ways. The series invites us to reflect on how the events of our past can reverberate into our future, a central theme in the exploration of wormholes. Science fiction has also delved into the concept of wormholes as a means of escaping reality. In Isaac Asimov's The End of Eternity, characters use these tunnels to manipulate time and create a utopia. But at what cost? This work raises questions about the ethics of altering time and the future, leading us to question our own decisions and the impact they have on the world around us. Meanwhile, in the realm of video games, titles like Portal use the concept of wormholes to create innovative gameplay mechanics. Players must think creatively to solve puzzles and advance the narrative. This playful approach not only entertains, but also invites reflection on the connections between different dimensions and how we interact with space. Finally, the representation of wormholes in popular culture is not limited to science fiction. Contemporary authors are beginning to explore these concepts in their works, expanding the scope of what wormholes mean for our understanding of reality. Books like The Girl on the Train examine the idea of decisions and their ramifications, albeit not directly, evoking the same sense of connection and the intersection of realities that we find in wormholes. The fascination with wormholes in popular culture reflects our desire to explore the depths of time and space. They remind us that while science may offer us answers, narrative also plays a crucial role in our understanding of these complex concepts. In the end, wormholes are not just doors to other worlds, but also windows into our own stories, desires, and possibilities. Wormholes have fascinated scientists and dreamers alike, but they have also brought with them a myriad of challenges and controversies. What happens when science touches the limits of our understanding? In this vast universe, where the laws of physics seem flexible, wormholes test our logic and our vision of the cosmos. To begin unraveling the mystery, it is essential to ask ourselves, do wormholes really exist? Although theory suggests they might be possible, we have not yet found concrete evidence to support them. Imagine that an apple represents our universe. If we cut it in half, each part would be separated, but by connecting them through a wormhole, we could travel from one part to the other at the blink of an eye. However, what if that shortcut is not as safe as we believe? The stability of a wormhole is one of the main problems faced by scientists. For a wormhole to remain open, a form of matter or energy that we have yet to discover, known as negative energy, is needed. This concept is so strange that it challenges our intuition. How can we have something called negative energy? It's like trying to visualize the absence of color in a rainbow. Negative energy could act as a kind of scaffolding that supports the wormhole, preventing it from collapsing. Another intriguing question is the nature of time in relation to wormholes. If we could traverse one, would we be traveling to the past or the future? The idea that we could change historical events raises a moral and ethical dilemma. Should we do it? What would happen to the decisions we make? These questions are part of a broader enigma that has been explored in science fiction and philosophy. And speaking of philosophy, what implications does the existence of wormholes have for our understanding of the universe? If these shortcuts through space and time are possible, does that mean time is more flexible than we think? This could challenge our notion of causality. In a world where events are not strictly chained, actions could have unexpected repercussions. Wormholes also lead us to reflect on the structure of the universe. Are we really alone in this vast cosmos? Some scientists suggest that if wormholes exist, they could serve as bridges between different parts of the universe, or even between parallel universes. This sparks the imagination about the possibility that other forms of life, other realities exist that we have yet to explore. However, research on wormholes is not without skepticism. Many scientists consider these ideas mere conjectures, speculations that, while intriguing, lack empirical basis. Can we trust theories that have not yet been proven? This is a dilemma facing the scientific community, between curiosity about the unknown and the need for tangible evidence. In this context, the dialogue between science and science fiction becomes vital. Often, science fiction stories provide a space to explore ideas that science has not yet been able to validate. Is it possible that these narratives, although fictional, guide us toward future discoveries? Imagination can be the spark that ignites scientific curiosity. As we advance in the research of wormholes, new challenges also arise. The technology we need to study these phenomena effectively is still in development. Will we be able to build instruments sophisticated enough to detect the negative energy needed to stabilize a wormhole? The answer to this question could change our understanding of the universe. Some theories suggest that if wormholes exist, they might be hidden in places we have yet to explore. This leads us to consider the possibility that there is much more in our cosmic environment than we can perceive. What mysteries await us in the depths of space? The search for answers is a journey that never ends. Meanwhile, it is essential to remember that, despite the challenges and controversies, research on wormholes remains a vibrant and exciting field. Each discovery, each new theory, expands our understanding of the universe and brings us one step closer to unraveling its secrets. Human curiosity is insatiable, and science is its most powerful tool. The story of wormholes is a blend of science, speculation, and philosophy. As we continue to explore, we realize that each answered question generates new inquiries. Are we prepared to face the implications that wormholes could have on our worldview and our perception of time? The adventure of scientific exploration has only just begun, and wormholes are just one of the many doors we could open on our path to knowledge. Ultimately, wormholes challenge us to think beyond the conventional, to question our beliefs, and to dream big. Although the path to their understanding is fraught with obstacles, each step we take brings us closer to the very essence of the universe. Curiosity is the engine that drives our quest, and in the end, perhaps the true wonder lies in the journey itself, rather than the final destination. What if I told you that wormholes are not just a physical phenomenon, but also a window into deep questions about our existence? By exploring wormholes, we not only delve into the interactions of matter and energy, but we also confront philosophical dilemmas that could change our perception of time and space. One of the most intriguing questions that arises is time really a straight line? Or could it be more like a series of interconnected points? In the context of wormholes, it is suggested that time could be something more flexible, like a river that can take different paths. This leads us to reflect on whether our decisions, our stories, and ultimately our lives are predestined, or if we can alter the course of our destinies. The notion of time travel through a wormhole makes us think about the nature of free will. If you had the chance to go back in time and change a significant event, would you do it? But what implications would this have for the present and the future? The time paradoxes that arise from these situations force us to consider whether time is a linear path, or if, in some way, our actions can reconfigure the fabric of the universe. Speaking of paradoxes, there are fascinating dilemmas like the well-known grandfather paradox. If you travel to the past and prevent your grandfather from meeting your grandmother, could you even have been born? This raises a troubling question. If wormholes allowed time travel, would it be possible to alter events in such a way that the necessary conditions for our existence were eliminated? The concept of negative energy also plays a crucial role in this philosophical discussion. For a wormhole to remain stable, it is theorized that it would require a type of energy that we do not yet fully understand. What does this mean for our understanding of the universe? If the existence of wormholes depends on something as exotic as negative energy, could it be that there are aspects of the universe that we simply are not equipped to understand? Delving into the very nature of reality, wormholes invite us to question our perception of time and space. The notion that we could traverse infinite distances in an instant challenges us to rethink our position in the cosmos. If time is an illusion, what role do our experiences play? Are they merely fragments of a larger reality where the past, present, and future coexist? Philosophy also intertwines with the idea of multiple universes. If wormholes can connect different points in space and time, does this mean that there are alternative versions of ourselves in parallel universes? Could there be a reality where you made different choices and thus live completely different lives? In this sense, wormholes are not just a physical phenomenon, but a powerful metaphor for our own choices and trajectories. Just as a wormhole could allow light to travel instantly from one point to another, our decisions can have repercussions that resonate throughout our lives. This leads us to consider the importance of every choice, no matter how small. The study of wormholes also confronts us with the fragility of our current understanding. As we explore these ideas, it becomes evident that we often find ourselves at the frontier of human knowledge. Are we prepared to accept that the limits of our science might just be the beginning of something much greater? As we delve into these concepts, it becomes undeniable that wormholes push us to question not only our understanding of the universe but also our very existence. What does it mean to be human in a cosmos where time and space may be manipulable? The quest for answers to these questions is not just an intellectual exercise, but an exploration of the very essence of our humanity. Finally, the implications of wormholes extend beyond physics. They invite us to reflect on our connection to the cosmos. Every time we look up at the sky, we confront the question of our place in the vast web of the universe. Are we mere observers, or is there a greater role to play in this intricate game of time and space? Understanding wormholes could be the key that helps us unravel some of these existential questions. So as we contemplate the possibility that wormholes exist and what they might mean for time travel, we must also think about what this reveals about ourselves. Science and philosophy are not separate disciplines. They are two sides of the same coin, which together can guide us in our quest for knowledge and meaning in such a vast and mysterious universe. The future of wormhole research is a fertile ground, full of possibilities and intriguing questions. What new discoveries will science bring in its quest to understand these fascinating phenomena of the universe? From research laboratories to theoretical studies, scientists are increasingly interested in exploring the implications of wormholes for our understanding of the cosmos. One of the most exciting areas is the search for evidence supporting the existence of wormholes in our universe. Although they are theoretical concepts, some researchers are using advanced computational simulations to model how these tunnels might behave in space-time. Could observations of background radiation or certain anomalies in the movement of stars give us clues about their existence? The idea that we might detect a wormhole seems straight out of a science fiction novel, but science is advancing rapidly. In the race to understand wormholes, interdisciplinary collaboration becomes an essential tool. Physicists, astronomers, and even philosophers are joining forces to tackle the most complex questions. How can we reconcile general relativity with quantum mechanics? This is one of the most pressing questions in current physics. If we manage to unify these two theories, we could gain a clearer insight into how wormholes work and perhaps open the door to new technologies. Advances in technology also play a crucial role. With more powerful telescopes and more sophisticated observation techniques, scientists are getting closer to unraveling the mysteries of the universe. Could these tools help us detect signs of wormholes? Imagine a future where telescopes can visualize distortions in space-time that suggest the presence of these tunnels. Technology is rapidly changing our approach to research. In a more abstract sense, the exploration of wormholes also leads us to question our understanding of time and space. What if wormholes were the key to connecting different parts of the universe? This could imply that time, as we understand it, is not as linear as it seems. This perspective could revolutionize our view of the cosmos and our place in it. Future research could guide us toward a deeper understanding of the nature of reality itself. On the other hand, simulations and mathematical models continue to enhance our understanding of wormholes. With each advance, scientists are uncovering more secrets about how these tunnels function. What are the necessary conditions for their formation? The more we understand, the closer we will be to answering fundamental questions about the universe. However, not everyone is convinced that wormholes are real. There are skeptics who argue that these phenomena are mere theoretical constructs with no basis in reality. As research progresses, it is essential to maintain a critical spirit. Could we be chasing shadows instead of concrete realities? This is a dilemma that scientists must constantly face. The implications of wormholes are not only scientific, they are also philosophical. The possibility of traveling through time and space raises questions about fate, free will, and the nature of existence. How would our ability to alter the past or the future affect us? The answers to these questions could change our way of viewing life and the universe. The future of wormholes could also impact the search for extraterrestrial life. If these tunnels allow for quick access between different parts of the universe, they could be the key to understanding how advanced civilizations move. Could wormholes be transportation routes for intelligent species seeking to explore other worlds? Science fiction has explored these ideas, but scientific research could offer more tangible answers in the future. In the end, the path to understanding wormholes is filled with challenges. Each discovery brings new questions, and each answer opens the door to more mysteries. Will we one day be in a position to explore these fascinating phenomena? Human curiosity drives us to move forward, to seek and discover more about the vast and mysterious universe we inhabit. As we look to the future, it is essential to remember that science is a constantly evolving process. Research on wormholes may not yield immediate results, but every step we take brings us closer to a deeper understanding. Perseverance and imagination are key in this quest. Each new theory, every experiment, and every discussion brings us a little closer to unraveling the secrets of the universe. So, while the future is uncertain, what is certain is that the exploration of wormholes will remain a captivating topic that will capture the imagination of scientists and dreamers alike. And as long as we continue to ask, investigate, and explore, the journey has only just begun. Often, when we talk about wormholes, we imagine an intergalactic journey through tunnels in space-time. However, the question that arises is, could these cosmic phenomena influence the way we build technology in the future? In a world where theoretical physics and a technological innovation seem to be in constant interaction, wormholes could be the key to unlocking new potential in science and engineering. The idea of using wormholes in technology is not just a science fiction fantasy. What if we could harness the curvature of space-time to create new forms of transportation? Imagine a transportation system that not only takes us from one point to another on Earth, but could also connect different places in the universe. Understanding wormholes could open the door to the possibility of instantaneous travel across vast cosmic distances. But is it possible that advanced technology is already being inspired by concepts from theoretical physics? Let's think about quantum computing. This field, which is at the frontier of modern physics, is based on principles that, although complex, have surprising parallels with the idea of wormholes. Just as wormholes can connect different points in space, quantum computing seeks to connect qubits in entangled states, allowing calculations that seem challenging for classical computers. Could it be that, in the end, understanding wormholes leads to breakthroughs in this area? Negative energy is another intriguing concept related to wormholes that could have technological implications. But what does negative energy really mean? In simple terms, imagine that negative energy acts like a kind of glue that keeps a wormhole open and stable. Without this energy, these cosmic tunnels could collapse. If we ever manage to understand and manipulate negative energy, we could be one step closer to creating technology that practically utilizes wormholes. What applications would this have in our daily lives? The possibility of creating devices that manipulate wormholes leads us to think about many fascinating questions. Could we have phones that allow us to communicate instantly with someone on another planet? Or perhaps machines that transport us to distant places in seconds? Although these ideas sound like something out of a science fiction novel, the advancement of technology often begins with a spark of imagination and a deep desire to understand the universe. Beyond transportation, wormholes could also influence the way we store and process information. Can you imagine a future where data flows through wormholes, allowing for almost instantaneous information transfer? This type of technology could revolutionize communication, making delays in data transmission a thing of the past. The integration of wormhole concepts into information technology could be the next big leap in how we interact with the digital world. However, not everything is a clear path. Research on wormholes still faces enormous challenges. Creating a stable and usable wormhole would require significant advances in our understanding of physics. But what if those advances were already underway in laboratories around the world? Science is a journey full of surprises, and often the most exciting discoveries come when we least expect them. Human curiosity has always pushed the boundaries of what is possible. In the past, concepts like aviation and electric energy were considered impossible. Today, the idea of using wormholes in technology might be seen as a fantasy, but history has shown us that imagination and research can make the unimaginable possible. The intersection of theoretical physics and technology is fertile ground for innovation. Could wormholes be the key to solving some of the most pressing problems we face, from energy to transportation? The answer may lie in how we explore and understand these cosmic phenomena. As we advance in our understanding of the universe, it is vital to keep an open mind. Research on wormholes and their relationship with technology is not only fascinating, but also invites us to imagine a future where possibilities are infinite. What other secrets could these tunnels in space-time reveal? The answer could change the way we see the world. In conclusion, exploring wormholes is not just an intellectual exercise, but a potential catalyst for technological innovation. Looking to the future, it is exciting to think about how theoretical physics could intertwine with the creation of technologies we have yet to dream of. The question remains, what else can we discover if we continue to explore these cosmic mysteries? The answer could be a journey we have only just begun to imagine. Wormholes have captured the imagination of scientists and enthusiasts alike, generating fascinating questions about their relationship with extraterrestrial life. Could these mysterious bridges in space-time be the key to connecting different parts of the universe, or even different universes? The idea that an advanced civilization could use wormholes to travel between galaxies or to communicate with other forms of life is both intriguing and exciting. The notion that wormholes could serve as intergalactic highways raises a series of questions. What would life be like on planets that are light years away, but could be connected through a wormhole? Imagine a world where inhabitants have instant access to other civilizations, sharing knowledge and resources quickly and efficiently. This could revolutionize our understanding of life in the cosmos. But what does this mean for the search for extraterrestrial life? Traditionally, scientists have searched for habitable planets within our own galaxy, using telescopes to detect exoplanets in the habitable zone of their stars. However, if wormholes are a reality, we might be limiting our search to a too narrow approach. What if advanced civilizations exist in places we have never considered, just waiting to be discovered? Theories about extraterrestrial life and wormholes also lead us to reflect on the possibility that these civilizations might be able to manipulate the fabric of space-time. Could they have developed technologies that allow them not only to travel through wormholes, but also to create them? The idea that other forms of life have reached a level of advancement that enables them to challenge the physical limitations we are still exploring is astounding. This makes us question, what kind of technologies could exist in the universe beyond our current understanding? Some scientists have speculated that if wormholes can exist, they might also allow for the existence of civilizations that have evolved in completely different ways than we have on Earth. What kind of culture, technology, and way of life would those who travel through these cosmic shortcuts have? The imagination runs wild. creating visions of societies that have learned to live in harmony with interdimensional travel. And not only that, wormholes could also allow for instant communication between distant civilizations. Can you imagine a conversation between beings from different worlds, exchanging ideas and knowledge through a wormhole? The idea of a cosmic internet, where civilizations connect and collaborate, opens up a range of possibilities that could change our perception of life in the universe. Nevertheless, the existence of wormholes raises ethical and philosophical questions. If we had access to these fast lanes, how would we decide who can use them? How would we regulate interactions between different civilizations? The history of humanity is full of encounters between cultures that have had profound consequences. Could we be prepared for the repercussions of intergalactic contact as we consider the role of wormholes in the search for extraterrestrial life? Questions about the future of our own civilization also arise. If one day we manage to understand and utilize these phenomena, will we become an intergalactic species ourselves? Could we be the pioneers on a journey into the unknown, carrying our culture and knowledge to other worlds? The idea of being ambassadors of humanity in the cosmos is both an honor and a great responsibility. In the realm of science fiction, we have seen representations of encounters between species through wormholes. Movies and series have explored these possibilities, often reflecting our own fears and hopes about what it means to be human in a vast and unknown universe. These narratives invite us to question our own existence and the importance of collaboration and understanding. As we explore the impact of wormholes on extraterrestrial life, it is crucial to remember that science is advancing by leaps and bounds. Each discovery about the universe, each new advance in physics and technology, brings us a little closer to unraveling the mysteries of the cosmos. The search for life on other planets is one of the greatest questions of our time, and wormholes could be a fundamental part of that search. The possibility that advanced civilizations exist using wormholes to travel and communicate leads us to an inevitable conclusion. The search for extraterrestrial life is ultimately a search for ourselves. In trying to understand what might exist beyond our world, we are also exploring what it means to be human. The connection between wormholes and extraterrestrial life invites us to expand our horizons and dream big. Finally, the exploration of this relationship reminds us that the universe is an incredibly vast place full of surprises. Who knows what discoveries the future holds for us? Perhaps one day we will find that wormholes are more than just simple theories. They may be the bridge to a new understanding of life, time, and space. In this journey of discovery, curiosity and imagination will be our best tools. So, keep an open mind and continue questioning what you think you know about the universe. Wormholes have captured the imagination of scientists and dreamers alike. But what do experts really think about their existence and potential? To address that question, we spoke with some of the world's leading theoretical physicists. Their opinions not only illuminate the topic, but also raise more questions than answers. One of the first to share his perspective was Dr. Javier Martinez, a renowned physicist from the University of Barcelona. In his opinion, wormholes are like a shortcut on a vast map. Imagine you have to cross a huge mountain and decide to go around it, which would take you days. but if you find a tunnel through it, you can reach your destination in minutes, he explains. This analogy makes the idea of wormholes more accessible. However, he also adds, the problem is that we don't know if those tunnels actually exist. The uncertainty is present in Dr. Martinez's words, who also mentions that while the theory is fascinating, the reality of their existence is a mystery. Theoretical physics is a field full of possibilities, but also limitations. Nature doesn't always behave as we expect, he comments. In this sense, it is essential to remember that science advances in steps, and often those steps are smaller than we would like. Another important voice in this conversation is Dr. Elena Ruiz, an expert in cosmology. She poses an intriguing question. Could wormholes be the key to understanding the origin of the universe? Her opinion suggests that if they truly exist, they could offer clues about how the cosmos was formed. Some mathematical models suggest that wormholes could be connected to different moments in the history of the universe, which could give us a completely new view of our past, she states. This leads us to reflect on the very nature of time. Dr. Luis Hernandez, who specializes in quantum mechanics, adds another dimension to the conversation. Wormholes and quantum mechanics are interconnected in surprising ways. Imagine that space-time is like a fabric that can be bent. If we manage to understand how they work, we could open the door to new ways of traveling through time, he explains. This idea raises a series of questions about the implications of such a discovery, not only in science but also in philosophy and ethics. The possibility of traveling through time via a wormhole is a recurring theme in science fiction, but is it really feasible? Dr. Ana Lopez, a theoretical physicist, tells us that the idea that a wormhole could allow us to travel to the past is tempting, but also dangerous. The time paradoxes that arise from this idea are complex and could destabilize reality as we know it. The notion that our actions in the past could alter the present is a concept that has intrigued philosophers for centuries. As we delve deeper into the topic, we find that not all scientists are optimistic about the existence of wormholes. Dr. Felipe Castro, a critic of the theory, argues that there is no empirical evidence supporting the existence of these phenomena. Science is based on data and observations, and so far wormholes are purely theoretical. This perspective reminds us that while imagination is powerful, scientific reality requires tangible proof. However, not all is lost. Dr. Mariana Torres, an astrophysicist, shares a ray of hope. Technology is advancing by leaps and bounds. What we consider impossible today could be reality in the future. Perhaps one day we will have the ability to explore these phenomena more directly. This invites us to keep an open mind and continue exploring the frontiers of knowledge. The opinions of these experts reflect a diverse spectrum of beliefs and possibilities. Each contributes their unique insight into how wormholes could change our understanding of the universe. Sometimes science is a journey in itself, says Dr. Martinez. We don't always reach our destination, but the process of exploration is equally valuable. Moreover, research on wormholes also raises profound philosophical questions. What does time really mean if we can travel through it? Dr. Ruiz points out that modern physics challenges our traditional notions of time and space. and wormholes are a clear example of this. These philosophical reflections invite the audience to question their perception of the world. Finally, it is important to remember that science is a constantly evolving field. Dr. Hernandez concludes, "We must always be willing to change our theories in light of new evidence. Humility and curiosity are our best tools. Thus, as we close this section, it is clear that wormholes remain a fascinating enigma that invites us to keep asking and exploring. It is a reminder that while science can be complex, curiosity and the desire to understand are what truly drive us forward. From the most abstract theories to the most practical applications, the journey through these tunnels of space-time has only just begun." Wormholes, those fascinating doors to the unknown, offer us a unique perspective on the universe and its workings. But why are they so important in modern physics? The answer lies in their ability to challenge our traditional notions of time and space. In this final journey through our topic, we will explore why understanding wormholes is crucial, not only for science, but also for our own comprehension of existence. When thinking of wormholes, many might imagine spaceships traversing cosmic tunnels. However, beyond science fiction, these phenomena invite us to question what we believe we know about reality. Could a wormhole be the key to connecting different points in the universe, or even different moments in time? The possibility that these highways of the cosmos exist leads us to a series of intriguing questions about the very nature of reality. Physics has taught us that the universe is a place full of surprises, and wormholes are one of its greatest mysteries. Imagine the universe as a vast canvas. Each star, planet, and galaxy is a brushstroke in this masterpiece. Wormholes could be the lines that connect different parts of this canvas, allowing light, matter, and perhaps even time to flow in ways we could never have imagined. But do these connections really exist? Can we ever be capable of traversing them? The study of wormholes leads us to question fundamental concepts such as time and causality. If we had the ability to travel through one of these tunnels, how would that affect our lives? Could we change events from the past or perhaps glimpse the future? These questions not only intrigue us, but also open up a range of possibilities that challenge the laws of physics as we know them. As we delve into the science behind wormholes, it is fascinating to consider how each discovery brings us a little closer to understanding the workings of the universe. Scientists have worked hard to develop theories that help us visualize how these phenomena might form and exist. From Einstein's relativity to more modern theories, each advancement provides us with new tools to explore what once seemed impossible. Moreover, the connection of wormholes with negative energy poses an intriguing dilemma. If these tunnels require a form of energy that challenges our current understanding, what implications does that have for our quest for sustainable energy on Earth? Perhaps by understanding wormholes, we are also one step closer to solving some of the most pressing problems of our civilization. Popular culture has embraced wormholes as a symbol of the unknown. From movies to books, we have seen how these phenomena are portrayed as portals to other worlds. But how far is fiction from scientific reality? The line between science and fantasy becomes blurred when we consider that many ideas once deemed absurd have become pillars of modern physics. As our technological tools evolve, so does our understanding of these concepts. Simulations and mathematical models allow us to visualize what was once only a dream, but will it be enough? Science advances by leaps and bounds, and what may seem like science fiction today could be a reality tomorrow. Are we prepared to face the repercussions of such discoveries? The philosophical implications of wormholes are equally fascinating. They invite us to reflect on our position in the cosmos and the nature of time. If we had the opportunity to travel through a wormhole, would we really change our history, or would we simply be spectators of a script already written? These questions lead us to consider free will, fate, and the very structure of existence. Future research on wormholes could open new doors not only in physics, but also in technology and space exploration. Imagine a future where intergalactic travel is possible thanks to our understanding of these phenomena. Would we become citizens of the universe, exploring distant worlds through tunnels that blur the boundaries of space and time? The search for extraterrestrial life is also intertwined with the study of wormholes. If these phenomena exist, they could be pathways for communication or transport between distant civilizations. What implications would this have for our understanding of life on other planets? Perhaps, in the vast universe, we are not as alone as we think. In conclusion, wormholes are more than just a simple physical concept. They are a window to our future and the possibilities that await us. As we delve into this cosmic enigma, we are constantly challenged to rethink our understanding of time, space, and our place in the universe. The exploration of wormholes is not only a journey through the cosmos, but also a journey toward understanding ourselves. So, the next time you look up at the starry sky, remember that you might be looking through a portal, not just to other worlds, but also to the future of humanity.